Hello, Internet. My name is Lyzi, and I am a developer advocate at Glitch, and I am here with...
I'm Melissa McEwen, and I work in developer education at Glitch.
And we are here doing our very first challenge live stream. Hooray! This is the first time we're doing this, so we're trying out a new format. If anything is weird or confusing, we have the chat open on the YouTube page. So if you have any questions, or if you can't hear us, or you can't see something, font bigger, etc., go ahead and put that in the chat. So thank you all who tried out the challenge, read the blog post, decided that you wanted to learn some more about Chart.js. I learned a lot while building this, and it was really fun. So I hope that you had fun too. The plan for today, for the next hour, we're going to take a look at the Chart.js Starter App, kind of walk through how it works, and then kind of take a stab at a few of those challenges. And we got some awesome submissions. Thank you, everyone who submitted. And we're going to show off a few of the super cool chart apps you made with a variety of different data. Super fascinating. I'm very pleased about it. Okay, so I'm going to share my screen, and then we can go from there. Screen 2, application window, share. All right. Can you see that? Yes? Okay, cool. So this is the Chart.js Starter App. It looks probably familiar. If you're listening to this, maybe you have already gone and poked around and gotten a sense of what this app looks like. If you haven't, totally cool. We're going to walk through it, so it's fine. So this app uses Chart.js, which is a client-side JavaScript library. Well, it is a JavaScript library. We are using it on the client side, meaning all of the code is being run in the browser, and none of it is being sent to a server to process and then be given to the browser. So everything that is happening here is happening in your browser on your machine. So this app uses Chart.js to display a bar chart and a pie chart showing world population by continent. And I picked this data set because it was small and therefore conducive to pie charts and bar charts and such things. Which, if you played with this and tried to use your own data, maybe you noticed that the pie chart is not the best choice of a chart for data that has 100 different categories, for example. But we'll get to that in a little bit. So Chart.js is a tool for making charts, and not only are the charts in the browser, they're also interactive. So if I hover, I can see the value both on the pie chart and the bar chart. And if you can see, the color changes slightly and becomes slightly more opaque as I hover over the bar. So walking through the code of this app, I think what we'll do is the same as in the blog post. We're going to go file by file and talk about the different code that was added to each part of the file, or was added, is in each part of the file.
So I don't need a database for this. It's just these two files.
Yeah, it's these 3 files here. There's no database because we are storing the data directly in the JavaScript that is being loaded into the browser, which is really nice. And as we'll talk about in a little bit, when we kind of remix and start working on the challenges, like, data becomes sort of a difficult, weird problem where once your data gets honestly much bigger than the data that we have here, you have to start thinking about managing it in a different way. But for this first example, the data is all contained right there. But great question. So here I'm going to hide this toolbar here. This view, by the way, is available for any Glitch app. If you go to glitch.com/tilde and then the name of your app, you can end up on this page where you can take a look at the code and the app side by side, which is super helpful if you are trying to explain something, or in this case, or if you want to make a change and see it happen on the other side as you're working on it. So here, and so for example, right, I can put like a client side. Oh, I can't edit it here. But anyway, forget it. If I was editing my project and I said edit my project here in this area, I could be like, awesome. And then as you see over here on the right, the word awesome was inserted because this code is actually running as I'm typing it. Take that out. So we have two divs here. They're both of a class chart container. And inside of that div, we have a canvas element. And that canvas element is empty. There's an open canvas tag, a closing canvas tag. There's nothing in it.
What's a canvas element?
A canvas, that is a great question. A canvas element is well, all elements on an HTML page are like inside of the body are pieces that you're adding to your DOM, document object model, the thing that you are looking at in the browser. And Canvas is a container for putting in cool visual stuff. And a lot of different libraries take advantage of the Canvas, including like for mapping. You can like dynamically using JavaScript and HTML, you can like dynamically add images and visual content inside a canvas, and it has its own magical way of working that I'm not super familiar with how the canvas.
So you literally draw on the canvas?
Yes.
Like a real canvas?
Yes.
Cool.
But you're doing it with code and words instead of with a paintbrush.
Neato.
The code is your paintbrush. So here in these, I have these two canvas elements, and each one has an ID. This ID is bar chart for this first one, and the second one is pie chart, because those are the things that we're going to put in there. Those IDs can be whatever we want. I just name them bar chart and pie chart so that we know what they are and can engage with them.
Can we zoom in a little?
Oh, sure, totally. That helpful, or should I do more?
A little more. Yes.
Wonderful. So if you'll notice here too, this tag here that says aria-label, this is here for accessibility reasons. When you are, some folks who are visually impaired in a variety of ways decide that they want to use a screen reader to help them look at the internet. And by including this tag here, the screen reader knows how to describe the thing that is actually on the page, where it might just be like, the screen reader wouldn't know what it is. So then it would just, in a voice, like a voice assisted tool would just skip over it. So, or describe it in a way that wasn't that helpful. So that's why we include those two there. Anyway, we have these two divs, and like a div is like a container on the page. And then inside of each of these divs, we have a canvas. And these canvases are here because the Chart.js library says make a canvas on the page, and then we're going to, when we make our chart in the JavaScript, it will be inserted into that canvas. So those are the main things that we are adding to this page. And so that's what's in the HTML file. In the style.css file, CSS is the styling for the page. And here, I added a couple of things just for visual purposes. So the canvas itself, I gave it a purple border so you can see the edges of the canvas. Obviously, that doesn't have to be there, but it's nice to like get a sense of what's actually happening on the page. And then here for anything with the class chart container, I added some code to make these two charts look nice next to each other or stacked on the page. So this is all kind of optional, depending on what you're trying to make and how you want the thing to look. I will say I'm not a designer. Fortunately, there's some amazing CSS if you start a project, glitch project via the Hello website or any of the Hello projects. You start with a few awesome CSS rules to make your page automatically look good from the get-go without having to change very much, which I very much appreciate because, again, not a designer. So most of my design stuff here is just to make it easier to see what's actually happening on the page.
We might want to remix this one because I think this is the base one. So then you can also show what remixing is like and why we do that.
Good point. Okay, so here on this tilde page, we on every page where you look at a glitch app, there's, for the most part, there's an option to remix the app, and remixing makes a copy for you that is all of the same code, everything that is in the file in the original project, but it's your copy, and you get to do whatever you want to it. So that's a great idea. Let's do this. Remix this, and our new project is called Better Gecko.
Great name.
Good one.
They're auto-generated names, and we always get some great ones.
Totally. So great. Yeah. So now we're in the edit page, which will show me the code full screen, as opposed to like that side-by-side view from before. But if I push this show button, it should open a new tab and show me the live app. And then as I change things in the code, they will change in the app as well. So it's just like before where they were side-by-side, but instead they're in two separate tabs in this view. So we looked at the HTML. And as you can see here on line 10, this is where we tell the browser, like, hey, we're going to need the code that is in this Chart.js library. Like, we're using this. So go and get it and make sure that we have it so that when the JavaScript runs, it knows what a chart is because it's defined in that other file.
And this is called a CDN, which means like it's a CDN hosts some code that developers can use on their pages, and anyone can use it basically. So you don't have to like upload the code to your like glitch project. You can just reference that URL.
Totally. And the documentation for different libraries will tell you how they want you to include their library. So the Chart.js documentation recommended doing it via the CDN content delivery network. Is that right? What CDN stands for?
Yeah.
And so it's a hosted version of this JavaScript library that that my app can dynamically go and get. Some libraries prefer you actually download a JavaScript file and add it to your project and use it that way. And if we were to do that, this tag here, the source, instead of being to this other website, the source would be to the file that's in our file tree. And that's what we're doing on line 16 here. While on line 10, we're saying, go get this JavaScript file from this other place. On line 16, we're saying, also go and get our JavaScript file from within our project. And that is, so that's what's happening on this line, and that's what it would look like if we were getting that locally. Cool. So that's the index.html. We talked about the style. So let's go and take a look at the meat and potatoes of this app here, which is in script.js. So this first part on the top, this is not strictly necessary, this global chart. The reason that I put it here is because in the index.html file, we're loading in Chart.js. And in doing so, we get this global object called chart. And that is accessible to all of everything that is being loaded into HTML, including the JavaScript. But inside of the editor doesn't recognize that this JavaScript file is going to be loaded into the HTML. And so it sees chart, and it's like, I don't know what chart is. So I'm going to yell at you about it. So if I uncomment this, or if I take this out, rather, you'll start to see these little red, this red guy show up here. It's like, I don't know what chart is. Chart is not defined. But
and in the future,
know,
like you'll be able to use like imports within client-side JavaScript, right? Probably.
Within Glitch?
I'm within just any JavaScript,
in general?
Probably, yeah. I think that's
I don't know.
Someday.
Is that on the roadmap?
Yeah, you'll just be able to add import, but right now you have to like just tell it, hey, we have this global.
Yeah. Hey, P.S. Don't freak out. I mean, and like this, it's trying to do you a solid, right? It's trying to be like, you typed a thing, and I don't know what it is, but we know better. And we're like, no, we actually do know what a chart is. So if I type global chart here, then we're telling the linter, like, cool, it's fine, we got this, we're on top of it. So kind of the first thing that happens in our JavaScript here is that we make an object called data. And again, this object can be called whatever you want. We just happen to call it data. And that this data is in an object format where there are keys and values. In this case, the key is the name of a continent, and the value is the number of people on that who live on that continent in thousands. So that would make Africa 1,216,000 people. Which is a lot of people, a lot more than Europe, and significantly more than North America. So that's the first thing we have, this data. And then, as I was saying before, this is a relatively small set of data. There are 6 values. That is really conducive to a bar chart and a pie chart. It's also really nice because we can paste it right into the code and not have to worry about like getting that data from somewhere else because it's small and self-contained, which makes for a really good example because you don't have to get like bogged down in a bunch of other stuff that can be annoying. So for the case of this, we have this small data set. Chart.js, the job of Chart.js is to create some tools that we can use out of the box. So similar to how you can buy a toaster and then put toast into it, you're not being sent a box of like metal pieces and screws and a heating element and saying, okay, put this toaster together and then make toast with it. So Chart.js is like the toaster. It's already been made. We just need to put toast in it. And the toast in this case would be data. Now I feel like I need to make toast like that somehow looks like a spreadsheet so that I can have like data toast in my data toaster. But in order for Chart.js to make a chart, in order for the toaster to make toast, it needs to have like bread in slices, right? So in order for Chart.js to make the charts, it needs to have data given to it in a very specific way that it knows how to read. And this is because computers are, trying to think of a better word than dumb, but like computers are kind of dumb. They don't really know how to intuit things. They don't know how to like take one thing and like smush it into another like we can with our brains. So we have to reorganize, transform the data into a format that Chart.js wants. And the way that Chart.js wants its data is for a bar chart, for example, it wants an array, which is a list of labels, which would be the continents, and it wants an array of data values, which would be the populations. And those are here on lines 32 and 35. So what our job is then is to take this data that is an object and turn it into these 2 arrays. And so that's what these 2 sections of code are doing. And this is all these kind of the creation of the data, the creation of these 2 arrays, that's going to totally depend on your data. Sometimes data will be in a different format and you need to readjust the way that you're creating these arrays depending on the format that your data is in.
It might be worth going into the console on the site to like print out like what it does to it, what they look like once these things finish transforming them.
A great idea. So here, after we go through these operations, I can do console.log continents. Oh, here I can do this, populations, and it'll actually show me both.
Ah, yeah.
So here, my starter app, I can open the console, so I have to pop it back in. There we go. I had it open in a separate window. So here in the console, I have these 2 arrays that are showing up because I said, hey, log these 2 arrays to the console. And I can see here there is an array of 6 values. There are 6 continents, and then an array of the 6 population values. So these are the 2 arrays that are created from that little bit of code.
It might be worth also showing what they look like if you had just written them out like yourself.
Yeah.
Because like the inspector, whatever
yeah,
that's called, formats them helpfully, but sometimes it's like, oh, what would this look like if I coded it myself?
Yeah. So I'm typing here. Let me make this bigger. Boom. Okay, so here in the bottom right, you can see I'm typing out the array as it would look. Europe, North America. This is exactly what you're not supposed to do on like a live thing, just like type things. So that's what or continent array. We'll call it continent array. We'll give it a value so that I can refer to it again later. So continent array. This is the array, and yeah, so in the like kind of raw view, if I was to write this in the code, I would do it in a list like this. Once the inspector is showing it to me, it's trying to be helpful and it's showing it to me in this like listed format. But the same thing for the populations. You can just put the values in 1216, 4436, 738, 9, 39.9. Let me just say numbers to you through your computer. Okay. There we go. So this is what it looks like once it actually goes into Chart.js. And if we wanted to, we could take this little array that we made, copy it, go back over to the script, and instead of putting this variable here, which contains this array, I can put in the actual array itself, and the app should stay the same.
Nice.
Thanks. And then we can do the same thing with populations here, and we have the same chart. So these are ostensibly the same thing. They are.
So Chart.js wants them in that format, and you had the data in that other brackety. So the data is in an object, and they want it in an array. If you tried to put an object in there, it wouldn't work, right?
No, it would get mad. Let's see what it does. So let me just copy pasta this guy. Copy pasta is the same as copy paste. More fun to say. So if I plug that in there, put some tabs in, make it easier to read. Yeah, this app is like,
no.
I don't know how to read this. I'm expecting to see an array, and instead you gave me some other thing. I don't know. And this is an example of how like computers, like it can't, this library doesn't know how to deal with it unless it's in the format that it wants. It's like, ah!
It can't even.
It fell over. So that's kind of that section of the taking the data. Yeah.
I guess like an advantage of like not, just putting the lists in each little chart is that you can reuse that data in the other chart.
Exactly right. So if for some reason, and as it tends to happen in apps, you have to change your data. Like, let's say that this is actually a typo and there are actually, 1,215,000 people in Africa, right? Then if I have the raw data down here, then I have to go and change it everywhere I put it. Versus if my data is up here and I'm actively creating these arrays from the data, then down here when we make a second chart, we can be sure that the data is going to match between the two charts because we're using the actual same variable that contains that data. And if it changes in one, it's going to change in the other. So that's more reliable. It's based on a programming principle called don't repeat yourself. Whenever you have something that you're doing over and over and over again, it's best to try to contain it in a function or a variable so that it can be reused in the future. And if you have to change it, then you only have to change it once, which is super nice. So down here and we kind of started getting into it a little bit, but down here where we are actually creating the charts. So on line 30, we create this variable bar, again, could be called anything, where we point bar to the actual bar chart canvas, the empty canvas that we created in the HTML.
And that is like the thing that's in like the hashtag or pound sign on the HTML element. Hashtag. Hashtag bar chart.
Yeah, it's the ID. So
yeah.
yes, in the CSS, if you were to refer to this, you would use a hash in front of it, and then you could add styling rules that are specific to this ID, to the element with this ID. And as you'll remember, in for chart container, we put a dot in front of it, and the dot symbolizes a class. The difference between a class and an ID is that an ID can only be used one time. It can only refer to one specific element, versus a class can be used multiple times. As you see here, these two divs share a class. And so...
but if you like renamed the ID, you'd have to change your code too, because it references specifically that one.
Exactly, yes.
Hashtag so bar chart.
Yeah, we're looking for hashtag bar chart. And and so if I changed the name of bar chart here to like bar charty, for example, the app would not know what to do, because it's like, I don't know what bar charty is. Then it
seems very easy to confuse Chart.js.
What do you mean?
Like,
like to confuse the library?
Like, yeah.
Yeah, totally. Right. So here, this is looking for bar chart, but bar chart doesn't exist. Bar charty does. So it's like, I can't get at bar chart because that doesn't exist. That's not a real thing. But if I change this here to bar charty, then it should work just fine, because it knows that it can find bar charty. Yes, so here, yes, we have this variable bar, and we're like, bar refers to this element, which is super nice, because when we make a new chart, this capital C chart, this is our tip-off that we're using Chart.js, because we're using the capital C. We make a variable bar chart, and inside of that variable bar chart, we make a new chart. And the first thing we have to tell that chart is where on the page it's going to go. By creating this variable bar, we were able to tell the chart in a concise and clear way, put the chart here. And this, the like parentheses here, you can see glitch friendlyly highlights where the start and open and close parentheses are. There are two things that we're giving to Chart.js to tell it to make a chart. We're telling it first where the chart's going to go, and secondly, inside of these curly braces from here to here, we're giving it all of the options that we want it to use inside of that when it's making that chart. Importantly, this includes the actual data that's going to be charted. And so we have to tell Chart.js that. But the term for this here is arguments or parameters. You'll hear them called when you are calling a function, or in this case, it's a constructor, and you need to give it some information in order for it to do its job. We are giving it the information it needs to do its job. And all of this is defined in the Chart.js documentation, which I'm going to actually open up here, chartjs.org. And the Chart.js documentation is great because it will tell you for each type of chart, like, oh, you're making a line chart. Cool. Here are all of the properties that you can tell me what to do, and I will make them.
But you don't need all of them, right? Like, it has defaults.
Definitely
if you don't specify.
Not. Yes, there are definitely defaults. Exactly. You don't have to specify all of them. It'll yell at you if you don't. But like if you're missing something important. But the things that it really needs are, as you can see in this example here, where am I going to go, and what type of chart and what data do you want in it?
But the background color, that's optional, right?
Yeah, background color is optional. Border color is optional. Border width is optional. But this is what really can like change your chart to make it pop.
Make
it super awesome.
You don't want just like a gray chart. I think that's what it does if you just don't give it any.
Oh yeah,
super boring. Yeah. Well, I mean, no insult to gray charts. They could be fine. But if you have a lot of data, it might make it hard to see the differences.
Well, we can try it. So let's take these 3 lines that are defining the colors and comment them out. And I can do this by doing command slash, which
Oh, wow.
automatically
I haven't tried that yet.
comments that out.
To know.
Yep. So here, if I take out the like color and the border and stuff, we just have, you're totally right. It's like this like kind of translucent-y gray. I like the red better.
Yeah.
So I can
I use like colors that like the names of colors? Like, could I use the background color? Could I just say red?
You can if it's like an official color name. What is the like color authority for
there's like
colors?
And the names of the color. There's like this group, I guess, that like they decide names of colors that are valid, and there's even one named after like someone's daughter. And there's like cornflower blue. You can find a list online.
Oh yeah, okay. Official colors.
Nope.
Oh, this is not what I want.
Official HTML colors might get it.
Yeah, official HTML colors. Aha! HTMLcolorcodes.com. Excellent. So here you can see, make this a little bigger, these colors and their associated hexadecimal code and RGB code. And in the code in my app here, we're using RGBA. And RGBA is the color values for how much red, how much green, how much blue, and how much opacity. So here I'm using the same color, but I am saying for when it's just the regular background, make it 20% opaque. So mostly so very translucent. And then for the border, though, make it opaque. But like if I was like, oh, what if we do, 70%, then it's a bit darker versus the 20% that it was before.
And you can make like the bars different colors, right?
Yes, totally. And we do that here in the pie chart.
Oh, yeah.
I thought that it was confusing having because each bar represents population. Like doing them in different colors felt confusing to me, but that's totally doable. You just have to use here, instead of doing one color value, it like in the pie chart down here, we have an array. You can tell because of the square brackets. It's an array of different color values, and each one is, if you notice, there are 6 color values, the same way that there are 6 continents and 6 populations. It matches the number of elements that are actually going to be on the pie chart. What I don't know, I'm curious about, is what if there is a different number of colors in this array than the number of colors. So let's comment out one of these and see what happens.
It turns gray.
Yeah, it turns gray. It still has a border though, because there are 6 in the border. But like, what if I comment out this random one, and then does that one get a gray border?
It loses its border, it looks like.
Oh yeah, what happened was because I commented out a weird one, or like one in the middle instead of the end. Everything got bumped up, and then the last one doesn't have a border.
Yeah.
Interesting. Cool. Now we know.
Someone in our chat says bring back the pop, but because I don't know where they're from, it could be like pop like soda or pop like the sound. So
the pop up?
Oh, the pop up maybe? I don't know. Well, Flim Flam Jim, if you have some clarification, let us know.
Okay, so I've kind of been bouncing around here, but yeah, the basic idea, make a chart, tell it where the chart's going to go, and give it a bunch of options. If we pop over to the blog post here, which hopefully you read, explains kind of how all of this works a little bit more. Oh yeah, and if you see in the blog post, you can see the manual arrays that Melissa pointed out that we show. This is what the arrays, look like when they are created. Blah, blah, not blah, blah, blah. It's very fascinating. Highly recommend. We listed out these 4 challenges here. So we are going to try now in our what's called Better Gecko project to do some of these challenges and give them a try. So we already remixed it. Check. Nice. Step 1 down. So the first thing here, it says replace the data in the starter app with data you find fun or interesting. Now, I mentioned earlier that the way that the fact that this data is pretty small is a benefit, because it means that we can just like copy paste it right in here. Blog post, I link off to awesome public data sets. These are typically really big data sets, and it's not like necessarily the most conducive to this type of charting. And so if you kind of went on here and were overwhelmed and decided to not do it, I apologize. Since the blog post, I found this other super duper awesome similar set of data called awesome JSON data sets. And this data is already in JSON format, which is the JavaScript object notation. And that's the format that this project uses here in this object, this data object. So that's already a super good format for what we want. So scrolling through here, and I was like, what would be interesting, fun? Aha, United States population table. Okay, let's see how many 0 to 100-year-olds there were in 2010. So if I click here on this data, I get this chunk of blob of JSON here. And I don't know why I have a little extension that formats the JSON. It's working in this tab, so I'll show it to you here. But here you can see that this data set is an array. It has 101 items in it. And each element in the array is an object. So this first object is for age 0. There were 1,966,000 females, 2,054,000 males. This is from the census, and the census in 2010 asked for male and female, didn't ask about other genders, so that's why the data is constructed this way in this data set. It is not an endorsement of any kind of gender binary or anything. It's just how the census collected the data.
So H0 is like babies, right?
Yeah, totally. Anything less than a year. So, and you know, the census, as you can see, these are nice big round numbers. The census, this kind of aggregated data is rounded, and you know, not obviously like people filled out their little census form and then had a kid like the next day. So that you know might not have been accounted for. So these are not like super strenuous detailed, but this is a cool data set. It would be fun to make a chart about it. So cool, great, we have the data. What do we do with it now? There are kind of two options here. I could take this blob, select all, copy, go over here, make a new variable called data 2010, which is where it's from, and then paste. Give it a second. It's trying to paste. It's like, aha, there we go. But as you can see, I'm gonna get the scroll bar over.
We'll never get to the beginning. Oh, thank goodness.
Yeah, right? So I can do this. I can throw this in here, and you know, glitch is really nice, and it doesn't like wrap it and like make it really tall, so we have to scroll a whole bunch.
Oh, you can turn on wrapping, but you might not want to, because
maybe not in this case.
Yeah.
How do I do that?
You go to your little user icon on the top right, and then
wrap text. Oh, yep. I see. So yeah, so this is not that bad.
Still quite big.
Yes, and you'll see the syntax highlighting here. It like gets to here, and it's like, I'm done. I don't want to highlight it anymore.
Wow. Yeah.
But I think for this case, we can leave this here. I will make sure to post another version of this. I'll link to it from the README of the starter project. But there's another way to do this where you actually take the data, save it in a separate file, and then dynamically load it into your project. And I'll show you an example of that. But for now, we can just do this way. I'm also trying to be conscious of time. So here we have this variable, data 2010. Yes, we're going to make some cool stuff. So the way that the data was structured previously, we have Africa is a key, 1216 is the value. So it's a single object with keys and values. In the case of this data, as you can clearly see from this view, we have an array of objects. And each object has information in it that we want. So we need to kind of refinagle these little transform section to transform our new data into the arrays that we need to make charts, right? So what do we want to make a chart of? I think that of the data included in this data set, I want to know how many total people of each age there were per year. Gender stuff, not
So like a
not as interesting.
histogram.
Yes, pretty much over time. So in order to do that, we're gonna copy some of the construction from down here. So we'll make a excuse me. Come on, computer. Okay. No, my keyboard is freaking out.
Uh-oh, is the JSON too big?
No. Let's see. I think that it's just it was just my keyboard itself. Okay, so we have ages, make an empty array, and then we'll make another variable called total people. Sorry, hold on one second. Okay, total people. And then what we're going to do is we're going to go through each object in this set of data and then add the ages value to the ages array and the total number, or the age value to the ages array and the total number of people to the total people array. So we can say data 2010 dot for each object. And so what this is doing is I'm creating a function here.
Ah, ES6 syntax.
Yes, there's a lot of ways to make a function. One of them is to use this fancy arrow. Another one is to write function and take the arrow away. These two things, they don't do exactly the same thing, but for our purposes, they do the same thing. So we'll use this syntax for now. So the first thing we want to do is we want to, inside of this object, we want to get the value of age. So let age equal object dot age.
And sometimes I just like run this with just console log obj or whatever I choose for the object, what it's iterating on, just to see what the data looks like. Just to make sure.
Oh, yeah, totally. Yeah, because especially if it's not sitting right here, we don't necessarily know what it looks like. So that's a good idea. So console.log obj.
And what for each does is it just goes through every like data point and it's just like it prints it out for us right now, or does something to it depending on what we tell it to do.
Totally, yeah. It goes object by object and does something. And in this case, we said go object by object and print out the object to the console. So we can.
So all our objects look like that. They have the age and the total, and that's what we care about.
Exactly right. Exactly right.
And we access them by the key, for example, age.
Yes. So yes, exactly. That's totally true. So and we can do a console log here too, just to make sure. So we know that each object has a key called age. So if we do object.age, and we say log each age, awesome. This is exactly what we should see. the age value in each object is 1 larger than the previous object.
So we're going to just take that and put that in the arrays we made, and then we can use those arrays, right?
Exactly right.
Cool.
So we can say, let age equals object.age. And then similarly, we're going to do the same thing for the populations. Total pop equals obj.total. And then we're going to use some fancy JavaScript here to add these to the array. So we have an array called ages. And then the way you add something to array is you use push. So array ages.push age. And then total people.push total.
And that just pushes it to the end of that ages array, right?
Yes, exactly right.
Cool.
So then what we can do here is, let's just do a console log for ages. And that way, each time this loop happens, we'll see the new value of the ages array. So we can see here, at first, the array just has 0 in it. Then it has 0, 1, then 0, 1, 2, then 0, 1, 2, 3. And because each time we're adding that value to the end of the array. And then the same if we change this to total people, then you can see that, yes, there are 100. By the end, there are 101 values. The starting ones, these are the number of 0-year-olds up to the number of 100-year-olds. Cool. So now we have these 2 arrays. Heck yeah. If you'll notice, I'm not removing any of the code from before because we're just, we're working on data 2010, and that's a different variable, so we don't have to change anything else. But for sake of making things less confusing, I will comment out the parts we are not currently using. That rhymed. That was a rhyme. So here, now that I commented out data, the code doesn't know what data is because I commented it out. So the code is like, I don't know how to do this because I don't know what data is. That's cool. You don't need to.
Goodbye.
And it's also going to get mad down here because now it doesn't know what continents or populations.
Yeah, but now we have new data. So let's tell about the new data.
Totes. So here, let's do a bar chart first. So we have labels, which is going to be ages. Each bar is going to be a different age. And then the data is total people. And we can change the label because it's not population in millions. It's like total people in US of this age? Question mark? Yeah. I don't know.
Sure. I made a histogram yesterday, and like you can add more labels like to the X and Y axis to make it clearer.
Yeah.
I think that is understandable. Whoa.
So this is what our chart looks like right now. This is a really cool way to see the wow, a lot of young people in 2010. Not as many older people. This is really cool. It's a little bit hard to read, but the hovering makes it nice because then you can like see for a specific age, how something would look. Another one of the like challenge pieces here, right, is to change the colors. And I'm curious, like instead of putting 100 colors for background color, like is there a way for me to do like a gradient or something? Like, can I put like 2 colors and make it a colors? Let's see. When supplying colors to chart options, you can use a number of formats. You can also pass a canvas gradient object.
Whoa.
Cool. It's an opaque object describing a gradient. So let's see. Let's look at this example. Where's the gradient? See, this is how you can tell I'm a developer, because I just want to copy paste something.
Yeah. Just tell
Interesting. So this is an example showing how you can make like an image background. We have about 9 minutes left, so I'd rather take this time to show off some other people's projects than mess with that. But if you make a gradient, send it to us, because we want to see it. So we only got a chance here in this live stream to go through one part of the challenge, but I still think that this one part is pretty cool. And we get this cool chart of like all these populations of people in the US in 2010. Very cool. And also here I have if you can see the scale, we start at 0 and then go up to 500,000, 1 million, 1 million, 1.5 million, and so on. This makes sense, seeing as we do have some of the lower numbers here that are lower than 500,000. But if, for example, we were only showing the data from ages 0 to 45, then it might make sense to actually make the y-axis start at a higher number, so that it's like you can see the variations more clearly, because the scale would not be as large. But again, do that, this is for further research. Okay, so are we ready to see what people made?
Yeah.
We got some amazing submissions. I picked out 4 that we are going to take a look at. This first one is from Awesome Lamb, and it is a DDR, Dance Dance Revolution Groove Radar. Are you familiar with Dance Dance Revolution and what a groove radar is?
Yeah, I think it shows like what like the song is like, each individual song, but I haven't played DDR in ages.
Oh, interesting. I'm trying to like hover and get more info. Interesting. So the groove radar is a pentagon-shaped marker that determines the difficulty of a song. Interesting.
Can we zoom in a little bit on that one that we're just looking at?
This one? Or this page?
The chart. What kind of chart is that, by the way?
I don't know. Let's take a look at the code.
I always call them spider web charts, but I don't know.
Oh, yeah. I wonder what the official name is. Well, we can find out in the code. It's a radar chart.
Yeah. Cool.
I love these comments. This is awesome.
Yeah, we love it.
This is so super great. So this is a perfect example of something that you can do with your own data, and it's got, it's reusing the array creating code, but making its own little chart, dude. This is awesome. Thank you, Tram Golam. That is super awesome. Here we have another one. This is showing Canadian population by province. Oh, yes. Thank you. Canadian population by province. Awesome. So Ontario, Quebec. I like that this one is in order by population. Unfortunately, it does make some of the smaller ones like a little bit less easy to hover over, but that's not. Ooh, see, there you can get it. That's not the fault of this app creator.
How many people live there? How many people live in Yukon?
Oh, I don't know. Let's go look at the data. Source. Okay, 35,000.
Wow.
There's more people in Nunavut than in Yukon? I had no idea. So this is cool because in this case, we have random colors being created by taking the RGBA values and throw in random numbers in there from 0 to 255, which is very cool because that should mean that each time we look at it, it has different colors. Yep. So if I reload the page, yeah, different colors each time.
Oh, cool.
Oh, that's awesome. I love it. Yeah, and these are the same two charts that we had before, but with this other cool data and these like sweet random colors. I love it. This is great. And it's very clear here from this data, like, oh, obviously most people are in Ontario. Cool. This super awesome one is it's a little dark, but this is meteorite impact. And so the blue here we have in the 1800s. There were, ooh, did you see that background?
Yeah.
Shooting stars?
Whoa. How did they do that?
Cool. And so it looks like it's an animation. Let's hop in here. Take a look. So awesome. Thank you for updating your README. It now displays the number of meteorite impacts on Earth per century since the 1800s. Updated colors using Solarized by Ethan Schoonover. So that's awesome.
That's a cool palette.
Let's take a look at that.
I use that in my terminal.
Ooh, yes, me too. Well, in my in my text editor that is not Glitch. But yeah, this is awesome. And then data sets were from NASA, meteorite data, excellent choice, data set. And then this background is created by this person, Locktar00. So the animation itself is in its own JavaScript file.
Interesting.
That's so really apparently cool. It is over on CodePen. Take a look at that. And then I'm guessing it gets pulled in here. Yes, in the HTML, we pull in that JavaScript file, the same as we're pulling in the script.js file. And the
looks like they're doing a canvas. Yeah, so it puts it on 2 canvases, and then I assume the CSS, they are resizing the canvas. So the background is a canvas, I think.
Oh, cool.
Wow, nice.
Yeah, cool. Awesome, totally. That's really neat. And then, it's this dynamic. Yes. So before, remember when I was saying, oh, we could put the data in another file and then go and get it. This is what that code that I was going to include would have looked like using this tool fetch to go and get this other data. Don't have to worry about that right now. But this data is, instead of being saved in this project, is actually over in this JSON file on the NASA website and is being dynamically added to the page, which is cool. And that is also really nice for data that's changing constantly, because then you can pull in that data. Awesome, amazing work. We have one more I want to show in the last minute here, and this one is showing the tallest buildings in the world. And I love these super bright colors. Is this also a radar chart?
Interesting.
Oh, let's find out. View source. Polar chart.
Huh, I've never used that type.
Yeah, that's cool. So a polar chart, it looks like, take a look, is like a pie chart, but instead of the various slices being like calculating the area, it's the like depth of the slice that represents a certain number of value. Oh, it looks like this is, oh, I see. So this one is using the building height data for a bar chart. This is still using the population data, but is using a polar chart instead of a pie chart. Which is super
so it scales it to show how big it is. But it scales it. Instead of making a percentage of the pie, it's like a percentage of the height of the pie slice.
Yeah.
Very cool.
Yeah, and I like this. This is gorgeous. Thank you so much, everybody who submitted their super cool projects. Thank you for tuning in. I'm gonna stop sharing.
People can still submit, right?
Yeah, totally. Please still submit. This form is going to be here. And then next Tuesday, we are going to put out our next challenge, which will be related to data, getting data, uploading data, finding information about data. So hopefully you can take the things that you learned here and apply them to that project and vice versa. And then as we build and grow for the next few of these, we can start making stuff that includes all the different pieces. If you have any questions, feel free to tweet at us, either at Glitch or at Lyzi Diamond, at Melissa McEwen, and or go on the support forums, support.glitch.com. That is the best way to get help. There's a huge, amazing community of Glitch users who are ready and excited to answer your questions and share their work. And, as always, check out glitch.com every week because each week we feature new, awesome, exciting apps that can give you inspiration and help you build more cool, super awesome stuff.
Thanks, everybody.
Thank you.